Thank you very much for joining today at the FDTD Satellite Applications webinar. We're very happy today to have Dave Riddell, the Science and Operations Officer from New York, and Andrew Orison from WPC. And the talk today is on the September 29th, 2023 New York City Metro Flash Flood event, a successful WPC-WFO collaboration from outlook to warnings. Next slide, please. This is part of an ongoing webinar series. My name is Scott Lindstrom. I do this with Dan Bykos out at CIRA. I'm at SIMS. We're always looking for presenters. So if you want to give a talk, or you want to volunteer someone else to give a talk, or you think there's been something interesting that's happened, give us an email, and we'll help you or whoever put a nice presentation together that you can talk to your colleagues about the excellent use of satellite data. Next slide, please. This should be short, about 20 minutes for the speaker. Send questions via GoToChat, or you can ask in person at the end of the talk. So we'll follow the talk with some Q&A. We should be done by 18:30. Don't press hold. Mute when not speaking. Take it away, Andrew.
All right. Yeah, thank you very much, Scott, and appreciate it, all the support there as well from Dan. So yeah, the New York City flash flooding event from September 29th. This really was a successful forecast collaboration, really from the outlook phase all the way in to the warning ops itself, including an array of IDSS that happened. Unfortunately, it was a pretty high impact event that occurred yet again in New York City itself. And you can see here just a couple of the backdrops here of in this case here, Brooklyn, showing the event where there was very, very heavy rain that occurred, of course, and you see the inundation with the area streets that was occurring, especially on the morning of September 29th and even into the midday and early afternoon time period. So Dave and I are going to do the talk here today, and I wanted to just show the outline here. We'll talk about the event summary and just some of the rainfall analysis associated with it. We'll get into the outlook phase and also the watch warning phase as well. So that spectrum essentially as we went into the event itself, spanning about 2 to 3 days in this case. WPC's MetWatch and IDSS support that we gave for WFO opt-in for the event, and then we'll conclude with some general satellite recommendations. You're going to see some satellite data sets in this talk. Okay, so with that in mind, no warning, really, Dave? Is that what happened up there at Upton? I'll go ahead and pass it over to you.
I know there's nothing like working a 12 or 18-hour shift and getting off and going to the grocery store a couple of days later and finding this on the shelf, right? Top of the daily news there, angry New Yorkers for something else this time regarding the weather, but that's what we had a couple of days later. But I think after the talk, you may think otherwise. All right, next slide there, Andrew. All right, some of the imagery from that morning. Andrew showed you a couple of things. Again, extensive flooding throughout the city. The middle picture there, if you were catching a flight out of LaGuardia on Frontier that morning, that's what you were walking through to get to your gate. This was an event that occurred very, early in the morning. So from about 1 a.m. to about 8 or 9 a.m. in terms of the duration. So this was one of those situations where the precip started late at night, early in the morning rather, and went through the morning commute. Picture on the right there shows you, I think that's the Williamsburg Bridge, which is along the east, crosses the East River there. That's not the East River, that's actually the water up over the roadway there underneath. Next slide. Okay, so interestingly, here's kind of an overview of the event. This was a challenging event for many reasons, from the guidance all the way up to heavy rainfall in the urban environment. WPC had a marginal risk on day 4, upgraded to a slight, and then with good collaboration from the slight to the moderate on day 2. The flood watch was issued for excessive rainfall that afternoon, and then during the event we had 12 flash flood warnings in and around the city, including 4 of those which were considerable, 2 of them within the city proper. Pretty good lead times for the urban environment there. Average lead time preliminarily was over 120 minutes, so not bad in terms of warning performance. Next slide. All right, rainfall summary. The image on the left shows kind of the, when you think about excessive rainfall in the urban environment, it's really all about the rates. And we're fortunate enough to have a pretty dense network of instruments run by the New York State Mesonet. So what you're seeing on the plot there on the left is the max rainfall rate, 1 hour rainfall rate within the 24-hour period that encompasses the event. You can see kind of down into Queens there, where Andrew is pointing out, you see some high 2s to 3-inch an hour rainfall rates. And as you go up into parts of Queens and then over into Manhattan, you see some mid 2s, but everywhere else you had 1 inch or under. And contrasting that for some from other kind of big events that we've had, this was a little less widespread in terms of the 2+ inch an hour rainfall rates over the city. So this was more confined to parts of Brooklyn and Queens, as opposed to a case like the remnants of Ida, where it was basically a citywide event. On the right-hand side, there's just kind of the storm total precip for the entire event. Again, generally 5 to 6 inches from basically Nassau County out on Long Island through the city, and then up through parts of Connecticut and lower Hudson Valley. Next slide. Another kind of view of that from MRMS, showing you the Q3 multi-sensor pass there, and you can see kind of where the max rainfall is. That from the analysis, those reds, those deep reds there are starting in the 5 to 6 inch range, kind of bleeding up there into southern Nassau County and southern Queens and southern Brooklyn, and then you can see kind of that pink color showing the 4 to 5 inch range, or 5+ up into parts of Connecticut. Looking at it from an ARI perspective, again, the max there is basically a 50 to 100 year event based on the rainfall amounts, and you kind of contrast that again with what we saw from the remnants of Ida, which was at a 1,000-year event through much of the city. So stark differences there, just in terms of both the impacts, but also the localized versus more widespread over the city nature of this event. All right, next slide there, Andrew. One of the things that we pay close attention to here is the rainfall rates, and I'm not going to read the stuff on the right, but you can read. This is Kennedy, which is located kind of on the southern part of Queens. You can see the 1 minute rainfall rates there, and then in blue, and then the kind of accumulated amounts there in red. And you can see that after kind of the initial thump from about 5 to 6:30 Z, where you had basically 2-ish inches. After that, it was kind of a slow slog there from about 7 Z all the way through about 18 Z. So most of the rainfall from the day fell out of that 8 inches that fell, a quarter of that, or 20% of that or so, fell within the first couple of hours. But the rest of the time, it was kind of a slog in terms of accumulation. So the point is, contrasting that with some other heavy rain events we've had, it didn't all fall within a couple-hour period, even though you had some pretty good rates there at the onset. And again, record rainfall and that sort of thing observed at Kennedy on this day. All right, next slide, and I think it's back to you, Andrew.
Okay, yeah, thank you very much, Dave. Yeah, so the next step here, we'll take a look at the kind of that outlook phase, as we were, ahead of the event. And we'll go ahead and talk about some of the guidance here that we're actually looking at. So include look at the MBM. And one of the things that's really interesting with this event, if you look at the lead time here, a good 3 days out, 72 hours, the 12Z MBM run from the 26th, I mean, the impact potential there for the New York City area in general, even Long Island, was really not that good. There wasn't much of a signal for particularly heavy rainfall. And so these lead times here, days 3 into at least the early part of the day 2 time frame, there wasn't much of a signal for anything that was really high impact. And keep in mind too that with the time frame of the MBM farther out, you don't necessarily have that HREF guidance in there like you do once you get into the shorter range time periods. And that's what you start seeing here with the MBM, is the differences once you get to like 48 hours and all the way through 36 and 24, the incorporation of the high-res guidance into the MBM, being a part of that entire ensemble suite with the membership there, starting to get into a situation where you're able to resolve the convective potential for this event. And that's what happened here, where we started seeing not only the guidance coming around to the idea that, okay, yes, this is going to be a pretty big event. It's going to get the timing, had to figure the timing out for a while there, but then resolving the convective details and that higher rainfall rate potential. And that's what you see here with the 50th, and especially like the 90th percentile of information here. You start seeing the high end threat there, getting rainfall amounts that were going to be 3 to 5 and then 5 to 7 inches, especially at 24 hours. And you can see here the probabilities for 2 inches, a good 24 hours out was pretty high, all things considered, around New York City. So that certainly started giving a level of confidence that this was going to end up being a pretty decent event. And then when we interrogate the HREF itself, as far as the ERO goes, it was really the initial run in WPC of that HREF on September 28th, where we went ahead and we're like, okay, we're starting to see, some of these bigger signals for heavier rainfall rates. Okay, we're starting to see some of the FFG exceedance probabilities increasing. We're seeing the overall outrate rainfall rate probabilities for like 1 inches and 2 inches. We're starting to see signals for that, and that was really kind of the key. We initially had a marginal risk that we issued for the update on day 3, and that was back on the 27th. But then we went ahead and saw the 0Z HREF run from the 28th there, and that's what really kind of precipitated that upgrade to a slight risk. And you can actually see in our discussion here how we were thinking that the flash flood risk, while conditional, certainly could be pretty significant, high in threat. And we actually were focusing very specifically for areas around New York City itself, northern New Jersey, and then up the coast into southern New England there into Connecticut. And generally speaking, that was where the consensus was for some of the heavier potential. You can see these probabilities here, for example, of getting 1 inch per hour rates and even some of the 2 inch per hour rates here. This is based off the neighborhood probabilities. You can see the potential there showing up in New Jersey and near the New York City area. And one other point I would make here, these ARIs, especially the 100-year ARI, that's something that we look at quite religiously in WPC. We use it certainly for our EROs and definitely on the MetWatch desk where we issue that MPD product that many of you are likely familiar with. Those are really kind of key tools, if you will, key data sets to interrogate for where we think that high-end threat could end up actually being. And then we did another upgrade to the ERO after the 12Z HREF run from September 28th came in. So 12 hours later, in this case, you're seeing how the probabilities were increasing for 1 and 2 inch per hour rates up here, very close to New York City, just south of the city itself, but like western Long Island and near the coast there of northern New Jersey. You can see some of the spread here in their probabilities north-south. So you had some latitudinal differences in the guidance with where the heavier rainfall potential is going to be. But if you look at the consensus of this, certainly suggesting some higher end potential, and especially over here, if you look on the left here, top left, seeing the neighborhood probabilities for 8 inches in just a 12-hour period. And this is, if you look at the event, this would have been going through 21Z on September 29th. And so that 12-hour window is like 3Z all the way out through, or I should say actually 9Z through 21Z in that case, which was really the bulk of the event, 9Z to 21Z on September 29th. These were the probabilities for just getting 8 inches, and fairly high, at least for that threshold, for those totals there. So definitely suggesting higher end potential. And you can see here too the 100-year ARI output as well. So we did upgrade that day after looking at the guidance to a moderate risk in the ERO for the day 2 period. So we had the moderate risk out. We coordinated with WFO Upton. We had a conference call that day for the upgrade, and this is ultimately what led to WFO Upton putting out the flood watch. And so that collaboration process showing everything from the ERO and then getting down to the WFO level, showing the watch issuance itself. So Dave, speaking of that, yeah, go ahead and talk a little bit more here about that watch warning phase, if you will, please.
Yeah, and you can advance to the next slide, Andrew. Once we get to the watch phase, the watch went out that afternoon. I think, don't know if there's a missing slide in there or not, but anyway, once the watch went out, the DSS started. We made the decision that afternoon. There you go. Maybe I'm back one. The DSS started. We made the decision that afternoon to actually send one of our meteorologists to the New York City Office of Emergency Management following day. And so we were putting the pieces into place in fairly short order for a potential excessive rainfall event with some pretty good impact. So that kind of started rolling into play just after the flood watch and the coordination call with WPC. Okay, next slide there, Andrew, and I think that's the setup here. This is always a challenge. Where the axis of heaviest rainfall is going to be. Is it Northeast New Jersey, is it New York City, or is it Long Island, Southern Connecticut? And you take the same amount of rainfall and put those in all three different places, you could have very different responses, from the river response to the west, to the urban response, and to not as impactful once you get out of Eastern Long Island and up into Connecticut, lack of the urban corridor. So, this was a pretty screaming signal, at least on our end, we thought, given the pattern, given the very sneaky on the right-hand side there, kind of innocuous inverted trough, just kind of positioned in the right spot along with the short wave there up at 300 and some pretty good kind of large-scale divergence aloft. Kind of setting the stage for the heavy precipitation, along with the focusing mechanism, kind of basically taking aim right at the city. All right, next slide there, Andrew, or two slides, I should say. So starting the morning up, I actually came in that morning to help out, and ended up being one of the two radar operators that we had that morning. So issued a bulk of the flash flood warnings. First warning went out very early as the precip got started. That was that first thump of the couple of inches in and around Brooklyn and parts of Queens. And as the morning went on, you can just sort of see the narrow focus kind of right along that corridor. There's our considerable flash flood warning out for Brooklyn that went on through the day there. And so you can see, you come up to Long Island, not much to talk about. You go into northern New Jersey, not much either. So just a very narrow band of precipitation aligned along with that inverted trough, and the whole thing very shortly or very quickly as the afternoon wears on, then starts to shift onto the east. And you can see, of course, all the warnings that went up and down as a result of that. So again, doesn't look overly impressive from a radar perspective, but the fact that you had that narrow band focused over the city for that long period of time there, gave rise to the impacts that we saw. Okay, next slide there. Satellite information, since I was working the shift that morning, had lots of satellite information up on my screens with me. One of the ones I love is the Mezzo sandwich. We did have, I can't remember if we called for it or it was automatically placed over the Northeast that day, or I guess maybe it didn't move. But we, looking at the Mezzo sandwich, you can see, look at the southeast flow kind of at the lower levels, just feeding right into the city there with kind of some of the cloud debris there you can see below. But just those cold cloud tops and that southeast flow kind of affecting that moisture in as the morning went on. Next slide there. The blended TPW is another one that I like. It's been around for a while. This is not this is a little coarse, but we saw the same thing with this recent event where you basically have kind of the East Coast version of an atmospheric river, where you have these 1.5 to 2 or a little bit higher, basically the 200% of normal-ish kinds of plumes originating well to the south and just fire hosing it right into the Northeast as the pattern evolves. And this was a case of that as well. And I remember looking at it that morning, seeing these values kind of just off the deck there as the morning went on. And when you see that, you're in for some activity. Okay, next slide. I think that's back to you, actually.
Yeah. Okay, so yeah, taking a look at some of the IDSS and MetWatch related services that WPC was providing on behalf of the WFOs that morning. So I was working the event as well, and so hopefully Dave read my MPD I put out that morning, where yeah, we were highlighting the significant threat for areas of flash flooding, in this case, numerous instances of that around the New York City area. So I put this out about 5:05 a.m. and so just a little bit after 9Z. And the idea here was really just to highlight the fact that flash flooding was likely and it was going to be impactful for the urban area, inherently sensitive and also highly populated. And the idea here was to just kind of message the overall threat meteorologically that was going to be supportive of the heavy rainfall potential, the rates, the persistence of those rates, and not only just showing the area of greatest concern, but talking about the just how all the ingredients are coming together. And in this case, integrating the satellite imagery. This is actually a static image of the proxy viz imagery, which we have access to in WPC. We get this through Sierra, and this is the GO16 proxy viz, and it's really helpful because you can see at night, a lot of the details in the low levels that are really kind of mimicking what you might see during the daytime with visible satellite images. So this was something I incorporated there. A lot of strong southeast flow, and just like Dave was showing there with the 1 minute imagery there in conjunction with the radar. I mean, there was just a lot of moisture coming in from the southeast, and we gradually had instability coming up as well. We had some coastal frontogenesis. There was an inverted trough, like David mentioned. So a lot of things were just coming together for a pretty big event, and incorporating not only just the geo, when we talk about the GO16 data in this for this event here, but also some of the polar data. And I wanted to show this here. This is the experimental Sierra LVT, the layered vapor transport product that we have. Thank you very much to Sheldon Cusselson out there at Sierra for providing this loop here. And one of the things I mentioned for this particular event, and it was mentioned in my MPD, I had noticed out here southeast of New York City, out over the Atlantic, you see here, like in the surface, the 850 and the 850 to 700 millibar layers in particular, you see this pooling of moisture out there, and you can see it actually advancing here off to the northwest. Now this loop encompasses basically the entire event. This actually starts on the 28th at 18Z and goes through Series Z on the 30th. But in the early morning hours of the 29th, you can see this moisture coming in right towards New York City. And so you had this bubble of higher concentrations of moisture, but then you also had it embedded within a low-level jet regime where it was aimed right into Long Island, right into New York City and so many adjacent areas there of the coastline. And that was something I had picked up on, and I was thinking, wow, this is going to really increase the rainfall efficiency. And that's what this product really is kind of good for doing, is showing what your efficiency could be, okay, if you get these areas of stronger LVT in place. And so that was something that was happening on the mesoscale that morning. Another experimental product here, this is actually the percentile rankings of the ALPW. That's the advected layered precipitable water product here. This is based on a climatology of only about 9 years, 2013 to 2021. But it's not much of a signal per se here in this particular product, but you do see a little bit of anomalous moisture pulling here, surface to 850 across areas of New Jersey and near New York City. So I just wanted to show this as another product that we definitely look at. So one of the other interesting parts of this entire event was whether or not we had a contribution from a tropical event. Now, I actually did not even think about this when I was doing my MPD that morning on the 29th, but then after the fact, it became rather clear, it seemed like, that there was the moisture that was offshore, and I showed it in the LVT product there from Sierra. This was actually likely some remnant pool of moisture, or think of it in terms of some kind of DNA related to what was Tropical Storm Ophelia, which had made landfall in North Carolina several days earlier. And so you had that entity with Ophelia, its moisture kind of get blocked out here, got caught underneath this ridge to the north, and then it got affected back to the northwest. And so that kind of just illustrates, again, how this entire event unfolded. And it was pretty interesting to see that a former tropical was definitely involved in this event. So as Dave knows, Dave joked with me the other day about how, well, this is a typical look at traffic in New York City pretty much every day, around the New York City area here. But that morning on the 29th, around 8:42, this was a snapshot of just how bad the traffic situation was. That was when the heaviest rains were coming through New York City, some of the heavier rates at that point. And in the bottom right here, this is actually the max unit Q, the max unit stream flow data from the CREST model that's with Flash. And this is another data set we look at very, very closely in WPC. And it shows you some of the inundation and the enhanced runoff going on here around the Brooklyn area, areas around Queens and so forth. Some of these adjacent areas in the Long Island where you're getting some pretty good flooding concerns at that point because of all the excessive rainfall. So Dave pretty much already talked about this surface map that morning, showing the very divergent look to the cloud pattern here. This is the infrared satellite imagery overlaid with the 12G surface map. Dave talked about the inverted trough, and you can just see how dynamic the system was just with this sort of V signature in the cloud pattern there with the convective tops kind of spreading out. And it's a very divergent flow, enhanced moisture transport, lots of convergence kind of pulled right into New York City itself. And then we had at least modest instability out there coming in as well, helping to enhance the rates. And of course, again, we talked about just the PW pool from offshore. Later that morning, we did issue another MPD, another look here. This is the infrared satellite image from GO16. The clean IR, you can see this very divergent look here again in the cloud pattern. So you know the forcing is pretty good through the entire column at that point. The event was ongoing, and the satellite imagery was really helpful for us for messaging this MPD here. And the idea was that the event was continuing. We're still seeing a lot of forcing, a lot of moisture transport, and that the threat of heavy rainfall is going to continue for several more hours. And as we get ready to wrap up here, I just want to make a pitch here about the Sierra ALPW. So I work with John Forsyth and Sheldon out there, Colorado State, and with Sierra, and it's this is it's an awesome product because it really does show you your source regions for the areas of deeper moisture. In this case, a lot of tropical moisture that was coming up in association really with Ophelia, what was once Ophelia, and then that moisture coming back here to the north and west. And it again, it really does give information about what kind of rainfall efficiency you could be dealing with. So once you have enough forcing, if you have the instability in place, if you have these little signatures for downstream moisture transport, it really can give you information about how your rates might materialize and also just the overall efficiency. And it's really good for identifying several different types of features too here. I mentioned a bullet point about how it can be used to identify not only forcing mechanisms, but just an array of different things like fronts and dry lines all the way down through tropical cyclones and your MCVs. So with that, we'll go ahead and get ready to wrap it up here. I'll pass it right back to Dave for the final slide.
Yeah, this is not unique. I actually found this. I see originated out at SIMS, but on the Eastern Region SSD satellite page. And I'm looking at this. I'm checking the box of all the things that we were looking at sort of collectively that day. Within AWIPS and online. And many of these boxes are checked here in terms of the data that we were using that day and up to that point and through the events. Don't forget to call the mesosector, your total precipitable water, your stability fields, your blended TPW, the layer ALPW, which is a little bit on the newer side, just a ton of different things to look at. And, like with everything else, over time, you figure out what tools in your toolkit you like to use for which kinds of events and which kinds of phenomena. And I think this is no different. So that layer ALPW, for those in the Weather Service, you can get that through a DAM add-on. And that's one that we've gotten to rely on a little bit more now for these heavy precip events as well, looking at moisture sources and moisture feeds. So have not done so much with the web-based stuff down at the Sierra at the bottom, but those percentile rankings and such look like they, when you're putting it in sort of a quote-unquote climatological context, is something that I think there's some value to be had there too. So we'll leave you with this, but I guess at this point we'll turn it back. Andrew, I don't know if you have any final comments.
No, I think you covered it well there, Dave. Yeah, appreciate it very much. And yeah, we can pass it back over to Scott and Dan.
Okay, thanks very much for an interesting talk. We do have a couple questions. I see Dan Lindsay is unmuted, so take it away, Dan.
Thanks, Scott. Can you guys hear me?
Yes.
Okay.
Hey, Dan.
Hey, Dave and Andrew. Thank you for a really interesting presentation. We were looking at this case actually, shortly after it happened too, and that sandwich loop that you showed, Dave, that showed sort of a training. It's sort of like training convection is what it looked like. I'm not sure if that's really what it was, but you sort of get these cold cloud tops that then reform just south of New York City and then move up over and over again. It seems like that was kind of a key to the total rain totals. My question is, this seems like very much a mesoscale or even sub-mesoscale phenomena. Is that the type of thing that the models like 2 or 3 days out are even capable of capturing? Or I guess what I'm getting at is, I don't know that this is such a small scale thing that sort of happened to set up right there. I just wonder if we even expect the models to be able to capture something like that.
Yeah, I can make it just real quick. I mean, this is where, yeah, I agree. And the fact that, you know, even a day and a half out, we had some of those probabilities of, you know, even low end probabilities of greater than 8 inches. You don't see that very often. So there's clue number one. But I think, you know, going forward, this is where things like WAFs and some of the other finer scale modeling that is under development, I think is going to be able to help us out in these situations. But to us, and you know, I don't know, Andrew, maybe you have a comment on that. You know, to us, when we start seeing these from things like from the HREF and such, somewhere, right, where you have, you know, greater than 5 inches. You know, we here at the office use the 3-inch and 3 hour. That's kind of our first level of, okay, we have to pay a little more attention to the flooding potential. I mean, and this was sort of off the charts from that. So, and then it becomes a question of, is it New York City? Is it Long Island? Is it, you know, somewhere further to the west? And, you know, oftentimes you don't know until you can start with your mesoanalysis and you're getting close to warning operations.
So that graphic that you just had up, this one, was this like a 24-hour forecast roughly?
Yeah, this was from 12 on the 28th, so roughly 24 hours. In fact, yeah, it was the event really kind of got started about maybe 18 hours or so from this point, and then certainly by 24.
Yeah, I mean, this is pretty impressive to me. It seems like it captured it pretty well. All right, thank you.
Okay, we have another question. I saw it and then something happened. I can't see any, but I'll give you the gist of it. Is this was from, yeah, I'll have to look again, but the gist was what do you expect the partners that you're messaging to be able to do with this kind of information that you're getting them? So I think it was mostly a DOT person from DOT, and you're telling them this might be happening. What kind of action do you think is reasonable to expect for them to do?
Well, for New York City, it's very specialized. They have an entire flash flood emergency plan that starts with WPC outlooks, their actions that they do, you know, up to 3-ish days out, and they ramp up their operations as the event draws closer based on the DSS that we provide them. In a case like this, where you're looking at these kinds of the potential for these sorts of excessive rainfall rates, and keep in mind, you know, the remnants of Ida from 2021 is not that far in the rearview mirror. They start to do preparatory things all over the city for that, and you know, if we could tell them, you know, Queens versus the Bronx, they would love that. But obviously, back to sort of Dan's comments from earlier, you know, very, very tough to do on a borough level. But basically, for New York City, the preparation is a function of the outlooks and products, the probabilistic information that we give them, and our briefings to them based on the flash flood emergency plan that they have in place for these kinds of events.
Thanks. And the asker of that was Ed Townsend. I finally found the question.
And
I know you, yes, and I know you just had a big rainfall event with a current system. What kind of, you know, 1 to 2 to 3 day alerts did you have out for this particular system compared to the more impactful one back in September?
That's a really good question. This was very synoptic. You know, this event that we just finished up, you know, 3 hours ago, very synoptically driven. And the global guidance, in fact, was hinting at this probably over a week ago. We had a snowfall event here over, what's today, Wednesday? We had a snowfall event here over last weekend, and it was sort of hard on the messaging side last weekend to keep control of the snowfall event that we were going to have. And we had, you know, upwards of a foot in, you know, north of the city across our interior zone areas. But knowing that this river and wind scenario and excessive rainfall scenario was following on the heels a couple of days later. So we actually reached that. We coordinated very early on in the game with WPC and with the National Water Center, the RFCs. And actually, WPC, I don't know, Andrew, I'll let you comment on this, but we coordinated actually on a day 5 moderate for parts of New Jersey, parts of the lower Hudson Valley, southeast New York, and down into Mount Holly's forecast area, based on the river potential and the excessive rainfall potential. The guidance was showing, a widespread 2 to 4 inches in an area that, was where stream flows were already flowing at the 90th or 95th percent, 75th to 95th percentile area wide. So this was, this was a situation where the guidance actually, even 7 days out, was fairly consistent with a signal, which you don't see very often either, or as consistent as you would expect for that far out lead time. So it was a pretty well coordinated event, collaborated event, I would say, starting last Friday, today's Wednesday, so like starting last Thursday or Friday, as I recall.
Yeah, Dave. Yeah, last Friday. We put out the day 5 moderate risk in our ERO for from WPC, and it was a really, really good team effort as far as the collaboration went for this event, because the signals were definitely there in the medium range period. And it's not, I mean, this was actually the first day 5 moderate risk that WPC has ever put out, at least since we've been operationally doing the EROs in that time frame, days 4 and 5. So for it to show up on day 5 and then for it to persist the way it did, minus some of the tweaking of the details all the way into day 1, I think that was a success story. And so the messaging was really about as good as you could probably get, at least from the forecast perspective. For this, the signals were definitely there, and like Dave said, the National Water Center was involved in this process too, and they were very helpful.
Okay, I'm mindful of the time. I'll just ask one final question from Brian Curran. Are there satellite clues to provide IDSS at longer time ranges for core partners to spin up and act versus just react? I suppose you've shown the ALPW might be one of those. I'm wondering if you can think of any others.
I would argue, yeah, I mean, I'm a big fan of the ALPW product, and then the newer experimental products with the LVT and the percentile ranking state. I think those can be really, really helpful because it can show you what's happening, well upstream, away from an area that you think could eventually have a threat for heavy rainfall and flash flooding. So these products here, they can really kind of tell you how things are coming together from a distance. And so you can compare this kind of information with the model guidance to see, just how all the ingredients are going to be coming together. So it can give you some hints as to how potentially anomalous an event could be. It could, at a minimum, it'll help to facilitate that decision-making process when you're making a forecast, and it can aid in the confidence levels that you have, even at somewhat longer time ranges as well. It's not easy for sure, but it can give you some helpful clues.
Okay, thanks. There are also some comments like "Good show, Dave and Andrew" from Sheldon. So people have enjoyed this. So have I. Thank you very much for giving this presentation today. And with that, this FDTD satellite application is over. Thanks for listening, and we'll see you next time.